Hello everyone, I am Zihan, a first-year PhD student in Zhang Group at the Chinese University of Hong Kong. In this video, I will show you how to configure CHEMSMART, including server, Gaussian, and ORCA. The first step is to locate the CHEMSMART configuration files. Following the successful installation in the previous video and the configuration via make configure, users can now find the default tilter/.chemsmart directory, which contains configuration files for the server, Gaussian, and ORCA. The second step is to configure the basic user settings. Users can go to the .chemsmart folder and open the user settings YAML. Here, you can set your account information, Scratch directory, and email address. This allows you to receive a notification email from the cluster once your job is completed. The next step is to create a server configuration for the cluster. First, users need to identify the scheduler used on the cluster. Users can do this by checking available comments, such as which spatch for snrm or which qsub for PBS. If there is output, the scheduler is available. Otherwise, local mode is used. After identifying the scheduler, users can copy the corresponding YAML template and modify it as needed. For example, you can copy slurm YAML to a new file, such as user1 YAML. This template is already usable, and users can further customize some parameters. The first part covers the basic server settings, where users can specify parameters such as maximum wall time, memory, and the number of CPU cores. Also, the basic setting for PBS is similar to slurm. You can copy the PBS YAML template in the same directory and modify it accordingly. Then you can select one server when submitting your jobs. In the working directory, a script named CHEMSMART sub-jobname.sh will be generated, which contains the corresponding server settings. The second part is extra commands. These commands are automatically inserted into the generated submission script to prepare the runtime environment before submit jobs. And they are automatically generated by CHEMSMART. In the third part, we configure how Gaussian runs on the cluster. First, exe folder defines the Gaussian path. Then, local run and Scratch control how the job runs. Next, conda environment, modules, and scripts set up the environment. Modules ensure that all required dependencies are properly loaded on the HPC system. Users can also add extra modules for Gaussian. Finally, environment variables define necessary variables. Users can modify the Scratch folder here. For ORCA and NCI plot, these settings are the same. After server configuration, users can create a YAML file for their each Gaussian project. Go to the .chemsmart Gaussian directory and create a new project configuration based on a template, such as P1. In this file, you can define parameters such like the functional basis set, solvent model, and other options. For example, if you want to study a system containing palladium and iodine, iodine can be added into the list of heavy elements so that it uses the def2 basis set. And you can also change the solvent model to SMD with water. For Gaussian and ORCA project YAML settings, by default, gas setting is used for optimization, frequency, IRC, and other jobs, and the solve setting is used for single-point calculation. Users can also customize the setup. For example, run optimizations with a solvent model, define a customer solvent, or perform all calculations in the gas phase. Users can add TD for excited state calculations and can also add customized keyword, such as dispersion corrections. By default, CHEMSMART runs a frequency calculation after optimization, and users can disable it by setting frequency false. After the configuration, you can submit Gaussian jobs using a single command. The -s option specifies the server. -p selects the Gaussian configuration. And the capital P allows you to get molecular structures directly from PubChem website. You can also use -c to set the charge, -m for multiplicity, and -l to assign a label, and perform a geometry optimization job. After that, you can run another command to perform a single-point energy correction with SMD water. For the output files, the .com file is the input script generated by CHEMSMART. The .py file contains the job-related information. And the .sh file includes the server configuration and the submission details. Similarly, you can also use another Gaussian YAML file for your project. For example, you can create a file named P2 YAML, where the MO62X functional is used together with another mixed basis set. Also, in P3 YAML, you can set up gas phase calculations using the MO62X functional together with another mixed basis set. Next, you simply need to change the project flag from -p P1 to -p P2. This allows you to use a new set of project settings for the Gaussian job. The P3 YAML we just configured can also be used to run a gas phase geometry optimization of palladium chloride with a single command. In the Gaussian input file for P2 project, you can see that the ECP for the iodine atom is automatically included. The same applies to input files generated using P3 YAML. Users can inspect the .cln file to verify the computational method. For ORCA, the process is similar. You can create your own configuration file, such as P2 YAML. Just like Gaussian, users can also directly customize various parameters as needed. You can then use ORCA to submit a geometry optimization job using an input file like h2o.xyz. If a job fails, for example due to an incorrect multiplicity, an .arrow file will be generated in the output, which contains information about the arrow. The last part is users can also run Gaussian and ORCA jobs locally using CHEMSMART. Similar to submitting jobs on a cluster, CHEMSMART provides a local YAML file in the .chemsmart/server folder. Users can open this file and customize settings, and also check and modify the local executable path for Gaussian and ORCA. Next, we can create Gaussian project setting files in the same way as on the cluster. When you run jobs locally, you should use run instead of sub-s. For ORCA, the workflow is the same. You can use CHEMSMART run to quickly run the ORCA jobs locally. In summary, make sure the scheduler, executable path, and the environment are correctly configured. The server YAML controls where and how jobs run. Gaussian and ORCA YAMLs control what calculations are performed. In the subsequent tutorials, we will cover more examples of running Gaussian jobs.